Lab 2 Charge Tape Revisited by Caitlin Schmidt. For the introduction, we have the purpose, which is to further examine data from Lab 1 using GlowScript as a computational model to calculate the electric force and a charge on the tape. We'll represent tape as a line of charges instead of a point charge to account for the charge distribution on the tape. And the key findings were that the charge on one segment of tape was 2.49859 times 10 to the negative 8th coulombs. This value is more than twice the charge calculated in the previous lab. Have the models and assumptions. The assumptions is that the air resistance is ignored and that each piece of the U-tape has the same charge and that charge is spread evenly throughout the piece of tape. Models use our observational model, which is based on the same setup and data as Lab 1, and the computational one, which treats the tape as a line of charges to compute the electric force and the electric charge. Key principles. So we have Coulomb's law / electric force, which is the force between two charged objects. And we have the equations down there, and the electric field of the distributed charge, which is the net electric field, the gravitational force, which is the force of attraction between two objects with mass, and Newton's second law, which is the net force on an object is equal to the rate of change of its momentum. Observational model has a system of two charged U-tapes. The surroundings are the base tape, the supports, and everything else in the room. The initial values is that there's no electric charge on the U-tape, so Q equals 0. The procedure was that tape A and tape B quickly are peeled from the base tape, giving them a positive charge. The positive charge is conferred by its attractions to a negatively charged object, and when tape A is brought nearest ascended tape B levitates due to the repulsion between the like charges of the tape. And the distance between these tapes was also measured, and there are some diagrams of what that is. Calculations. For Lab 1, these are the computational results. So the magnitude of the electric force and gravitational force on the tape was 2.15 times 10 to the negative third newtons. And the magnitude of charge on one piece of tape was 1.0667 times 10 to the negative 8 coulombs. And then Lab 2 observational results, which were measured during the procedure, which is the length, the mass, the width, and the distance. And then the length, mass, and width are on one piece of tape, and the distance is between tape A and tape B when they're repelled. For the GlowScript model, and these are the initial conditions that were set up, and the most important part of this is the equation for the electric field, which is shown with the arrow. The model was updated from Lab 1, where the arrows are, so it has the magnitude of each point charge and the mass of each point charge, because we're doing multiple point charges. Here is the last part of the GlowScript model. This has the calculation of where the top and the bottom tape are, and then the arrows are pointing to the most important parts, which is the electric field at the top tape and the force of the electric field on the top tape. Final results for the GlowScript model, which the output is the magnitude of the electric force, the magnitude of the gravitational force, and the magnitude of the charge on one piece of tape. And it basically just shows the distributed charge in between the models and errors. So the model discrepancies are that the model assumes gravitational electrical forces are equal. However, there are likely other forces acting on the tape. And treating the tape as a multiple point charges was way more accurate than treating it as a single point charge. Potential errors are that the two pieces of tape may not have had the exact same charge, and mishandling the tape could have caused charge inconsistencies. And again, we did not account for other surrounding forces. For the discussion, so this is the what if you had modeled each of your tapes as a single charge and then compare the estimated value that you got using your experimental data to produce a point charge model to the value that you get with your line charge model. So those are the two estimates, and this is the answer to why they differ and why the values are likely to be closer to the real value. So they differ because the estimates are based on different assumptions about how the charges are distributed. The line charge model is most likely closest to the real value. This is because it more accurately demonstrates the physical geometry of the tape, which is a long, thin object. So now for some concluding thoughts about the experiment. So modeling a charged tape by breaking it down into smaller point charges provided a more accurate way to calculate the total charge. And to achieve an even greater accuracy, we should divide the tape into infinitesimally small pieces to compute the electric field, and the point charge model is not an appropriate way to represent how charge is distributed on macroscopic objects, such as tape. For listening and for your time.